Right now, at this exact moment, a machine is drifting roughly 143 times farther from the sun than we are, and it is still talking to us. Its radio puts out 23 watts, less than the bulb inside a refrigerator, and by the time that signal reaches an antenna in the Australian bush, it has faded to roughly 20 billion times weaker than the power it takes to run a wristwatch. And we hear it anyway, 19 and a half hours after it left. Its name is Voyager 2. It launched in 1977, built to last 5 years, and it is now in its 49th. But the machine is dying. It carried 10 scientific instruments when it left. 7 are already dark, and another goes before this year is out. And in May and June, engineers at the Jet Propulsion Laboratory tried something on Voyager 2 they were not yet willing to try on its twin. Because if it goes wrong, the spacecraft freezes, the antenna drifts off Earth, and nobody hears from it again. So this is a story about a final message. But the final message is not the one Voyager 2 is about to send. It is one it already sent, and that message arrived in 1986, went straight into the textbooks, and took 38 years to be understood. 3 things to hold on to. The correction that rewrote an entire planet, the 2 degrees that nearly ended the mission in an afternoon, in addition, the Australian bush that points at the southern sky for a reason nobody chose on purpose. To understand what is coming for Voyager 2, look at the probe that went first. Pioneer 10 launched in March of 1972, designed to survive 21 months. It crossed the asteroid belt that engineers expected would shred it, became the first spacecraft to fly past Jupiter, and then kept going for another 29 years. By 2002, its plutonium had decayed so far it could not power the instruments at all, so controllers stopped asking for science and listened for the carrier wave instead. A carrier wave is not data. It is a bare tone, the radio equivalent of a pulse, and it says one thing: still here. The last time anyone heard that tone was the 23rd of January, 2003, from 7.6 billion miles away. It took 11 hours and 20 minutes to arrive. 2 weeks later, the Deep Space Network listened again and heard nothing. In 2006, they tried once more. Nothing. Nobody knew, on that January night, that they were hearing Pioneer 10 for the last time. There was no goodbye. There was a night when the tone arrived, and then a run of nights when it did not. That is what the end of a deep space mission actually looks like. Not a message, an absence. Which is why the message that matters from Voyager 2 is one it sent a very long time ago. Go back to the 20th of August, 1977. Voyager 2 lifted off from Cape Canaveral 16 days before Voyager 1. The numbering is not a mistake. Voyager 1, left later, took a faster route and overtook its twin inside the asteroid belt, so the names describe arrival order rather than departure. The 2 spacecraft were identical, 10 instruments each and 3 nuclear batteries making about 470 watts out of bricks of decaying plutonium. And bolted to the side of each, a gold-plated copper record, its cover plated in uranium, so that whoever finds it can date the launch by measuring how much has decayed away. A clock, running for whoever is on the other end. The mission on paper was modest. Jupiter and Saturn, 4 years of flight, and whatever happened afterward was not NASA's problem. What the engineers had wanted was the grand tour, using a lineup of the outer planets that comes around once every 176 years to slingshot one spacecraft all the way to Neptune. It was canceled in 1972 on cost, so they built something modest on paper and far more capable, in fact. 5 years was the design life. It is now year 49. Jupiter came in July of 1979. Saturn came in August of 1981, and immediately afterward, the platform that aimed the cameras seized, and engineers had to nurse it back by moving it slowly, never again at full speed. Then Voyager 1 used Saturn to fling itself out of the plane of the planets for a look at Titan, and it was finished with worlds. Everything past Saturn belonged to the twin that launched first, and this is where the story starts to bend. The 24th of January, 1986, Voyager 2 passed within 81,500 kilometers of the cloud tops of Uranus, and it had 5 days. 5 days at a planet no spacecraft had ever visited, and none has visited since. What we expected was a bland ball of gas tipped on its side. What we got was 10 new moons, 2 new rings, and a magnetic field strange enough to break the model. On Earth, the field tilts about 11 degrees from the spin axis and sits roughly centered in the planet. At Uranus, it tilted 59 degrees, and it sat shoved off to one side, as though the interior had been assembled wrong. Then came the part nobody could explain. Uranus had radiation belts, and they were fierce, second only to Jupiter's in the entire solar system. Belts like that are trapped, energetic electrons, and something has to feed them. And yet the magnetosphere, the bubble of magnetism wrapped around the planet, was empty. There was no plasma. Plasma is gas heated until its atoms come apart into charged particles. And every other magnetosphere we had measured was full of it, fed by moons venting material into space. Uranus had none. so scientists drew the only conclusion the data allowed. If the moons were not feeding the magnetosphere, the moons were not venting, and if they were not venting, they were geologically dead. 5 days of measurements, 1 planet, and an entire class of world written up as the freak of the solar system. 4 days after the flyby, Challenger broke apart over Florida. Uranus vanished from the front pages, and it never really came back. Voyager 2 reached Neptune on the 25th of August, 1989, 12 years after launch, on a spacecraft designed for 5. It passed about 4,950 kilometers above the North Pole and found a storm the size of Earth and winds near 2,000 kilometers an hour, the fastest anywhere in the solar system. And then it found Triton. Triton is Neptune's largest moon, and it orbits backward, which almost certainly means Neptune caught it rather than grew it. A captured object from the Kuiper Belt, wearing Neptune's gravity like a leash. Voyager 2 measured its surface at minus 235 degrees Celsius, the coldest thing anyone had measured anywhere. And that frozen, impossible world was erupting, throwing nitrogen 8 kilometers into a sky that barely exists. Getting there required a choice, and that choice is the reason this story has a deadline. To swing close past Triton, Voyager 2 had to fly over Neptune's North Pole and let the planet's gravity bend it downward, not sideways, downward, out of the flat plane where the planets live, aimed south permanently. They spent the spacecraft's whole future direction for a few hours over one moon. Hold that thought. Now, the correction. On the 11th of November 2024, a paper appeared in the journal Nature Astronomy. Its lead author was Jamie Jasinski, a space plasma physicist at the Jet Propulsion Laboratory, and he had spent years bothered by one nagging thought. Voyager 2 only saw Uranus for 5 days, and Jasinski had worked missions that orbited planets for a decade and watched them change. He knew what a 5-day snapshot can hide. So he did something almost nobody had bothered to do. He did not look at the flyby data. He looked at what Voyager 2 recorded in the days before the flyby, while it was still upstream, out in the solar wind approaching. That data had been in the archive since 1986, 38 years. It showed that in the days just before Voyager 2 arrived, the solar wind hit Uranus hard. The dynamic pressure, the force a stream of particles from the sun exerts on whatever it slams into, climbed by a factor of 20. That pressure crushed the magnetosphere, squeezing it from roughly 28 Uranus radii across down to about 17, near a fifth of its normal volume, inside of a week. A compression like that does two things. It flushes the plasma out, and it slams electrons into the radiation belts and lights them up. The empty magnetosphere, the impossible belts, both of them in one stroke. Jasinski ran the numbers on how often Uranus sits in that state, about 4% of the time. Voyager 2 had one pass at one planet in 1 week of 1 year, and it flew straight into the 4%. Arrive a few days earlier, and it would have measured a completely different world. In his words, they caught it at a freak moment in time. Think about what that means. For 38 years, our understanding of an ice giant, and by extension of the most common class of planet we have found around other stars, rested on a portrait of Uranus taken on the worst possible day. And the consequence lands hardest on the moons. Remember the logic. No plasma, therefore no venting, therefore dead moons. Titania, Oberon, Ariel, Umbriel, Miranda. If the plasma was never actually missing, if a freak gust of solar wind had simply blown it out of the system, the whole chain collapses. Those moons were never shown to be dead. They were assumed dead on the strength of a measurement taken during a storm, and some may have oceans of liquid water under the ice. That is the final message from Voyager 2. It did not arrive last week. It arrived in 1986, sat in a filing system for most of 4 decades, and only made sense when someone finally read the part we had skipped. Which brings us back to the 21st of July, 2023, and the 2 degrees. It was a routine day. The team sent Voyager 2 a planned sequence of commands. Somewhere in that sequence was an error, and the spacecraft obediently tilted its antenna 2 degrees away from Earth. Hold your thumb up at arm's length and it covers about that much sky. At 12.3 billion miles, 2 degrees is enough. Voyager. 2 could no longer hear us, and we could no longer read it, deaf and mute in the same instant, from a typo. There was a safety net. Voyager. 2 reorients itself several times a year, and the next scheduled reset was the 15th of October, almost 3 months away. 3 months of a 46-year-old spacecraft sitting in the cold, nobody able to send it a single instruction, everything resting on a routine it had been carrying since the Carter administration. Nobody wanted to find out. And here is where the choice at Neptune comes back. Because Voyager 2 doves south to reach Triton, it now sits so far below the plane of the planets that no antenna in the northern hemisphere has a line of sight to it. Goldstone cannot reach it. Madrid cannot reach it. There is exactly one dish on this planet with the power, the frequency, and the sky to command Voyager 2, and it sits in a valley outside Canberra. Deep Space Station. 43 was rebuilt from 64 meters to 70 in 1987, specifically to handle the Neptune encounter. The dish was enlarged for the flyby that sent Voyager 2 south. And because Voyager 2 went south, it is now the only one that can still reach it. On the 1st of August, the Canberra antennas combined their signals and picked up a carrier wave, a heartbeat. No data in it, nothing to read, just the tone. Still here. So, on the 2nd of August, they shouted. The Canberra transmitter normally sends commands to Voyager at 40 kilowatts. They ran it at 100, timed it for the best moment of the tracking pass, aimed it at a spacecraft whose ear was pointed 2 degrees away, and sent one instruction. Turn back toward Earth. The project manager, Suzanne Dodd, put the odds at low, then 18.5 hours for the command to arrive, and 18.5 hours for any answer to come home. 37 hours in total, with nothing to do but wait and be right or be wrong. At 29 minutes past midnight on the 4th of August, the data came back, streaming into a dish in the Australian bush from a spacecraft that had been shouted into turning its head. Glenn Nagel, at the tracking station, described the control room as jubilation, cheers, high fives, career professionals losing their composure over a radio signal. All of which is charming, and none of it solves the actual problem, which is arithmetic. Voyager 2 launched with about 470 watts and loses roughly 4 every year, partly because the plutonium is decaying, and partly because the hardware converting heat into electricity is wearing out. It is now down near 230. The radio alone needs about 200. There's no clever fix for that. Every year the number gets smaller, and every year the team decides what to kill. The plasma science instrument went dark in September of 2024. The low-energy charged particle instrument went dark in March of 2025. The cosmic ray subsystem goes before this year is out, leaving 2 working instruments out of 10, a magnetometer and a plasma wave detector. Then, on the 27th of February this year, during a routine roll maneuver, Voyager 1's power dropped unexpectedly, close enough to trip the undervoltage fault protection that shuts things down automatically and leaves the humans to work out how to bring them back. Mission manager Kareem Badarudin compared it to the safety net under a trapeze artist. It is there. The trapeze artist should never need it. So on the 17th of April, they turned off Voyager 1's low-energy charged particle instrument, running since 1977 to buy about a year. That year is meant to be spent on the thing they call the Big Bang. The idea is to swap out a whole group of powered devices at once, shutting off the heaters on the thruster fuel lines, and switching on 3 other devices that throw off enough waste heat to keep those lines from freezing. Do it right, and roughly 10 watts appear that did not exist before, and 10 watts buys 1 more year of 1 more instrument. The risk is exactly what it sounds like. If the fuel lines freeze, the thrusters stop working, and if the thrusters stop working, the spacecraft cannot hold its antenna on Earth, and a spacecraft that cannot point at Earth is not a spacecraft anymore. It is a plaque. They ran the tests on Voyager 2 in May and June of this year, not because Voyager 2 matters less, but because it has slightly more power to spare, and it is slightly closer to home, which makes it the safer place to be wrong. The spacecraft that gave up the northern sky for a few hours over Triton is the one they experiment on, so its twin does not have to. Voyager 1's turn is scheduled for no sooner than July, and if it works, they may even switch that 49-year-old instrument back on. They deliberately left its half-watt motor running, just in case. If you want to know how that turns out, subscribe, because this story is not finished, and the next chapter is being written in a control room in Pasadena right now. There is also a second countdown, and it is the one Yashinsky's paper made urgent. The Uranus Orbiter and Probe is the highest priority large mission in the current planetary science decadal survey. It would drop a probe into the atmosphere and spend 4.5 years touring the moons, for roughly $4.2 billion. And it has a window. Launch in June of 2031 or April of 2032. Use Jupiter as a slingshot the way Voyager 2 did, and arrive in the mid-2040s. Miss it, and Jupiter is not in the right place again until 2044, which pushes arrival into the 2050s. As of this summer, the mission has not been approved. So the corrected message, the one that took 38 years to read, arrives carrying instructions we may not be able to follow. It tells us we do not actually know what Uranus is. It tells us 5 moons were convicted on bad evidence. And it tells us this at a moment when the only vehicle that could go and check is a slide deck. Voyager 2 will not tell us when it is done. Pioneer 10 did not announce anything. It sent a tone on a January night in 2003. Then it did not send one again. And the difference between those 2 facts was invisible until it had already happened. It is still out there, intact and silent, tumbling toward the red star Aldebaran, 68 light-years away, on a trip that will take 2 million years. It is not broken. It simply cannot shout loudly enough anymore. Voyager 2 is on the same road. Some year the last instrument goes off, Some year after that, the transmitter cannot push a signal that Deep Space Station 43 can pull out of the noise, and there will be a tracking pass where the dish turns south and listens and hears exactly what it would hear if it were pointed at nothing. And then the machine keeps going, because that is what objects do in a vacuum. In about 40,000 years, it will pass within 1.7 light years of a small red star called Ross 248. In about 296,000 years, it will pass within 4.3 light years of Sirius. It will still be carrying the record, and the uranium on the cover will still be decaying, still keeping time, still counting the years since a species that could not agree on much of anything agreed to send its music into the dark. They are not keeping this machine alive because Uranus is interesting. They are doing it because somewhere in the archive there is always one more thing we measured and did not understand, and the only way to find it is to keep the machine talking. Voyager 2 is still transmitting, still measuring, still pointed at us. And in a valley outside Canberra, a dish wider than the wingspan of a jumbo jet turns toward the southern sky and listens for something older than almost everyone listening, whispering back at 23 watts. One day it will hear nothing. It will keep listening anyway,